So next, we can also apply this to a polyline. So towards that, let us draw in a polyline segment. So consider it to be something like this. So the reason why it is ticked, because a latest command what we had used for polyline during polyline demonstration had a width of this. So if you want to edit it, then you can use the pedit command. But okay, let us do that to have a clearer understanding of how the fillet will impact. So let us keep a width of say 0. Right. So with this, now invoke the fillet command, and rather now select the polyline. So the requirement is to select a 2D polyline. So once you select the 2D polyline or hover above it, you can see a preview of how the fillet is going to act upon. So once you click that, as the trim command is in the in no trim format, it has not trimmed, but all the edges have been filleted with the base radius that has been selected into it. So this is the application of the trim command. Alternatively, we also have the option to apply this trim to multiple surfaces. So let me just revert back to the original requirement, that is we have a single two-line object and as a polyline object. So we'll invoke the fillet command again, and let us increase the fillet radius to have a better view, and use the multiple command. So then it will ask for the first object, second, and so on. So that is, you can keep on applying this. Alternatively, so this will apply the trim option to more than one so unless we enter the enter command or come out of this using the exit command, it will keep on prompting it. So you can also use this if you have multiple surfaces that you have to do together, then this is one way of doing it. So the other key points for fillet is that if the trim mode is to be set on, then the filleting between the two lines will be done only when both the object length is more than the trim length. That means that if suppose consider this line, maybe you can use this measure method to check what is the line width. So this is approximately 147 mm and this is around 176 mm. So consider, let us try a fillet option of radius 150 mm. So in that case, if we apply it using a no trim command, then it will apply. But whereas if we enable the trim command, then for this radius, it will show that the selection is invalid, because the radius that we specify using a trim command should be lesser than the minimum length of the two objects that is going to be selected. And suppose if we want to override a preset fillet radius in the system menu, that in, so considering that we have a smaller object here and we do not want to set in the 150 mm radius in it. So in that case, when selecting the object, we can click in shift button and then select in to override the fillet that we have. That is, now the default fillet value will be set as 0. You can check here, even though the radius is 150 here, suppose if you want to cancel it out and then does not want to do it, then by using the shift option, the fillet is temporarily set to be of 0 radius. And in terms of layers that we are speaking about, if suppose the objects of fillet are on the same layer, then the fillet line will be on that same layer. So it means to say that this is going to get retained in the same layer of view that you are going to use. So next is that we can also fillet line segments in a polyline that are either continuous or separated by an individual line segment, and also that converge within the drawing limits. So in those cases we can still do it. Whereas if we try and fillet the boundary edges of an associated hatch, then it will remove the hatch associative because the boundary gets altered and hence it removes it. Whereas it will maintain the associative if the boundary is a polyline object. So in order to maintain associativity, you can convert the boundary line as a p-line object, a polyline object instead of a region, so as to maintain the associativity. So next what we have is the chamfer. So chamfer is similar to a fillet except it instead of a rounded edge it will have a straight beveled edge or a cross cut edge. So this again removes the sharp edges from the system. Chamfering of an element is predominantly used in assemblies. That is, suppose if you are assembling a shaft onto a hole, then the edges of the shaft will have to be chamfered so that it will get guided into the hole easily. And in cases of interference fit components and all those things, the chamfer is a key mechanical design element. So let's look into how chamfer is executed in AutoCAD. So now let's look into the same object. Let us just quickly remove this fillet command, or let it be there. Let's see how it's going to vary. So now on this two edges, let's execute the chamfer command. So you can type in by CHA, so that will call for chamfer, and so it again has the same options like in your trim command. You again have an option for the polyline and trim, and then the multiple selection. Then also you have a method option to select the chamfer either by specifying the distance or the angle between the chamfer elements. So let's go into the first method one, that is the distance. So once you specify that, you can also check in the no trim command to just check how it acts, because the trim is going to be same as in the radius, but let's see how the distance and the angle method is going to impact. So now we have selected the distance method, and by selecting the same methodology as in here, we have to give in. So before selecting the second line, we also have the option for selecting the distance. Now suppose if the given a length of 15 and then specifying the second chamfer distance of 15, now you can see the chamfer is, let me just do a quick measure here. So this measure command we'll look in the today's session as well, but let's see how it is going to affect. So you can see this is 15 mm from this vertex, and again this is 15 mm from this vertex. So this is how your distance command is going to act in. So similarly, if you take in the next option of angle, then you specify the angle of the chamfer. Generally all the angles will be of 45 degrees. So let us do the same for both the points. Now select the second line. You can see how this. So this is your 45 degree line with both the angles. So by this, these two objects are fillet chamfered by a 45 degree segment. Whereas if you are just going by the distance of the removed element, then you can go by distance method. So this is how it going to be varied. The rest of the options, that is the in the chamfer you have the trim, then the multiple and polyline is going to enact same as the fillet command. So now let's look into the next key part, that is editing using grips command. So far we have seen a lot of input commands that will help us to move the object, stretch or scale or rotate, all those things. So instead of specifying the command or selecting it through the menu, what you can also do is you can select the object, and you can see that there are certain points that are highlighted, squares that are highlighted here. So these are called just grips, and using these grips you can do the same activity. That is, instead of calling those commands separately, you can directly invoke it. Suppose if you want to move this object, then you can click on this grip that you want to do, and now the blue color grip is highlighted to red, and now you can move it across to any point that you require. So the next variation is stretching the element. So now let us look into the same object now. So once selected, and if you select one of the corners, then it gets into a stretch mode. you can see the variation between it. And in stretch again, then you have the object to cycle between the stretch or the lengthen option by using the control option. Right, so this is your command. So as I had used a control command, so now this element was copied and then lengthened to create this new segment. So the next option what we have here is the kind of a hidden command, that is, after selecting this, the default command is stretch or move based on the selection you have, but you pressing space bar, now it will go to the next point. So suppose you can see the next move point that is required, and also the angle of rotation that you can specify. That is, what we can do is, for the same angle but for a rotation of 45 degrees, sorry, yeah, so once you position it the next rotation point, then you can get the rotation angle after circling through the space bar. So now suppose the angle should be 45, then it's also affected. And now circle through it again. After rotation, we also have a scale factor that can be, that is, this line can be scaled internally. So suppose if you are giving a scale factor as 0.5, now it is affected as a reduction in line. So similarly, now cycling to the next part, it's where it comes back to the original point for moving. So these are the different options that we have within the grip selection menu. So alternatively, suppose if we draw a circular element or an elliptical element, we have additional points called as a quadrant grips. As if you hover it above, you can see that we can extend these circular diameter using this command, and the distance specified is not from the previous grip but rather from the center of reference, that is the geometric center. So by this also you can modify the dimensions of the component that you have already drawn. So this will also get applicated to text command also. Suppose if you go for an mtext command here and type in random text. So now once you click here, you can see this square button is to move the object, whereas there are two triangular grips that are available to specify the height, the width of the column as well as the height of the text element. So these are the functionalities of using a grip command. Suppose if you want to change the settings of the or the color of the grip setting, then you can go to the settings menu, and in options you can go to the selection tab to specify what is the grip size and what is the grip colors and what are the properties it should look into. So now let's look into the important terminology of today's session, that is the inquiry techniques, that is to investigate into the different components that we have inside the drawing. So this is heavily useful when you are auditing a drawing or editing a drawing. So in that case, this is of prime use to us. So let me just remove these objects and then replace them with a a rectangle and a polygon. So let me just move this. So let us remove them all here and focus back to our group here. Yeah, so let us look into what are the details that we can get through this info. So the first tool of inquiry is the ID point, that is the identification point of any vertex that we are interested in. So that is invoked by the command ID. So then the requirement is to specify a point from which we can inquire the IDs. Suppose if you want to get the detail of this vertex of your polygon. Then once you click on it, now you get a float menu stating that what is the position of that vertex along the x, y and the z axis. So this x, y and z is the current UCS coordinate system reference. So based on that you can identify where it is there. So also this data is available in the command line option also, because once you move your cursor away the info goes off, but when you highlight in your command line you can see the recorded data. So the recorded data is in x axis it is in -370, y 281 and z 0. So this is the use of the id command. Suppose if you want to reference to a previously set point, then suppose if you want to know the point as in here, then before clicking onto the point we'll click in next and at and then click on this point. So this will give a relative position to this with the last reference point. So by this we can identify the position of the different points that we have in our drawing. So the next option is the usage of the list command, list. So by listing, when we select any given object, all the parameters and properties of the selected object will get listed. So we'll look into the same polygon object now, and when we select the list option and select the object, so when clicking on enter it will return a command of descriptions. So now it says that polygon is of a polyline type. This is the object type, and followed with it denotes which layer the object is present. Next it will go to the defined space of the model, whether it's in the model space or the paper space, and next it denotes a handle. So this handle is a unique number alphanumeric identification. This is created by AutoCAD itself to identify the different objects for its own reference. So next what we have is the other parameters to stating whether this is going to be so based on the selected object type the parameters will vary for different objects. So now what it says is this polyline is a closed one and has a constant width of 0, and it has a total area of so much units and has a perimeter of so much units, and it has 6 coordinate vertex points, and these are the locations with the global UCS unit. So by this command you investigate into all the parameters as well as the properties of the command. So let us look into how this list command is going to act for different objects. So now let us select this circle and click on enter. So now with this circle what we are seeing is the object type is a circle and its properties are center point, radius, circumference and area. Whereas if we use the list command for the rectangle, this again is a polyline and it denotes in similar line to our polygon object. So this is the usage of a list command. So this you can do for any custom object that you have created to look into their internal properties. So next is command is called as the distance command. So till now what we have done was we had used the interactive menu that was available in the home bar to investigate into the various to refer whether we have plotted the correct length, correct angle and so on. So instead of this interactive command we can again use the command line prompt to type in distance. So this distance will give out the measured value in output terms. So suppose if we want to measure this distance, the first point in here and then the second point is here. So now dynamically you can also see what is the distance specified, and also by closing it out it will give additional information, that is what is the distance of that selected between those 2 points and what are those 2 points reference, that is what is the delta x, what is the delta y and what is delta z. So it means that it gives in the plane based reference as well as the individual line based reference of distance. So this is the utility of the distance command. So this means that you can use this distance command in different planes of reference also. So you get information within that same plane and also with the other plane modes. So like this we have different options to measure the different properties, that is the radius, angle, area or distance. So towards this we also have a group measure operation called as a measure geometric property. So once you invoke this property, this where you get a dynamic referencing of all the components that you want. Suppose if we highlight onto this object, you get the diameter of that, whereas if you move it over to here, you get the length and breadth of it, and if we select the polygon, you get the internal polygon details. So alternatively, you can also select one of the different options that you have, that is either selecting the distance, the radius, angle, area, volume or a quick measure, or again select between the different modes that are available. So we'll look into each and one now. So to start off with distance, it acts exactly as the dist command, that is you specify the 2 points from which the distance is plotted and reverted back. So once we select these 2 points, now you can get the output stating that this is a distance of 50, and also you get to continue the other options. So this command does not terminate until you terminate it outside. Next you have the radius command. Once you give it, it prompts for a arc or a circle. So upon selecting it, you get the radius of the circle. So alternatively, then you can select the angle, and again based on arc or circle or line of between two objects that you can select. So suppose if we want to select this object, then you can click on the first line and the second line. So thereby it gives the angle of reference for us. So next we have the area option. So in area we have submenus that are available. So we can check the area by the first default method by specifying the first corner point here, and next is and then the next point. Let me just close this. Okay, now let us repeat this command with the area option. The first point, second, the third, and the final, that is of required. So once you want to terminate it, click on enter. So now you get the total area as well as the perimeter of this command. So alternatively, we can also circulate within the area command and choose the other options that you want. So in area, after specifying the first point, you can also specify whether it's going to be of an arc or length. So once it's selected the arc element, so you can specify the surface of the arc. So based on that you can select. So now this is the selection arc, and we can get to know the area within it. So the next type of objects that we have is the object command. So in area we have the object. So this is by selecting the object you can calculate the area and perimeter. So this will apply on a whole. So we need not select the individual points and then request for the area, but rather select the object directly. So this is the area object command. So next what variant we have is to add an area or running it. So it means that once we click on the add area mode, it will keep on adding the areas of selection. Suppose if we want to select the area of these two, so now and then it's in the add mode. Now if we click on enter, it will result in the total area of the units, and also with latest selection it shows the separate area. So this is the add area option, whereas we also have an option to select the remove or subtract area within each other. So let us look into one by one. So suppose if we want to subtract the area of this point, so let us select the object method. So first we have to uh, select this object and then this. So now it gives in the net result area. You can check in the highlighted point here. So this is how your subtracted area will look like. So alternatively, suppose this can act best if you're operating on a internal object. So let us, as we have not mentioned any dimensions, it is easy to do it in the mirror way. So now clicking on to these lines, now we have got this object. So now let us look into what is the resultant geometry after subtracting the areas of the circle with it in it. So in the subtract mode, what you get is you directly go into a negative command as you start in a negative. Let's look into it. Now I'm just using the right button to continuously select the requirement. So we are selecting the area and selecting the subtract area and selecting object. So once we start selecting the objects, you can see once the subtract mode is enabled, it turns in red. And if you click on enter, what it does is it calculates the individual area of each component, and then that is the latest component, and then subtracts it from the total area that had been cumulated from earlier. So as there was no reference object available, it continuously goes on the minus object. So this is why if you again select a different object here, now we can see the total area going in negative, but the intended objective is to subtract this from the area. So what we can do is, first let us uh, select the areas that needs to be subtracted, that is with these 4 box, and once computed and click enter, now let us add the area and select the addition object here. So with this you can get the total area that has been available after removing these 4 holes. So this is how your subtract area can act in. So next we have a command in measure geometry for the volume of a component. But this calculates the volume based on the area times the height of it. So this is typically used for to find the volume of any solids or a region. So for 2D methodology, let us not dwell into this volume command. So the next command what we have is the quick measure. So by enabling this, we'll get the selection methodology wherein we can quickly analyze what are the different dimensions of our system is. So next we have a different modes. So this is to enable or disable the quick measure behavior. So if we select it as yes, so always we'll have the quick measure enabled even without selecting this quit option. So this is about using the different measure techniques that are available to quickly look into or investigate any components that we have. So in today's session of manufacturability, we dwelt a lot into the different options that AutoCAD allows us to define additional information into the drawing that will help us to identify different manufacturing techniques or ease of manufacturing. So the first was the hatch command, wherein we used this command to indicate shaded patterns which were used to represent a cross section for a mechanical component, or in case of civil representation it's used for a roof or an RCC material and so on and so forth. So there we looked into the several types of application of the hatch and also a gradient that can be used, and how the object of hatch can be selected whether through internal space or through boundaries. Then we looked into various island detection techniques which will help us to select the objects in that's of importance to us. Next we looked into the P-line command, that is the polyline, that helped to draw a sequence of objects that is both linear as well as curvilinear using a single P-line command. So this also we had looked into the various options that we can look into and draw. That is, we can draw uniform or an ununiform length. We can combine using lines and arc, and then we can add or edit the option by using a spline command or a curve fitting based on the input. So there were several options that P-Line command offered us to do. So next with P-Line we also looked into the P-Edit command, wherein we had the option to modify the polyline that were created in order to vary the width of the polyline segments, or modify the spline that were created to specify the tangent of the splines, and specify the orientation of the text using reverse command, join different line types, and so on and so forth. So following this, we had looked into the fillet and chamfer commands. So these were typical for any manufacturing industry or other design to ensure that the basic requirements were satisfied. One towards safety, that is to eliminate any sharp edges from the design, and to second for the structural integrity, that is to eliminate structurally stressed weak points. So towards this we looked into the fillet commands that will help us to specify the radius and also trim the commands, and next the similar way we looked into chamfer, by when we can specify either the angle between the 2 points or the distance between those 2 points. Then also we looked into how we can do common editing properties such as move, rotate, scale, all using dynamic selection using the grip techniques. So following which we looked into the other inquiry topics that will help us to analyze the design model that we have in hand. So we looked into ID command that will help us understand what is the vertex location of that point. Then we looked into list command, so that is to inquire more about the parameters and the properties of a selected object. So we also looked into the dist command that can use to measure the distance between the 2 points. Then as an extra measure, we also looked into the measure geometry command, wherein we were able to do expanded set of measurements, that is the distance, the radius, and then also we looked into area operation, wherein we were able to select or measure the individual areas and also perform add or subtract options to the area. And finally we also looked into how the quick measure command can help us to quickly grasp the dimension details of any object. So with this we conclude the week 5 of session, that is on manufacturability.